All right, Tuesday, March 24th, 2020. We're going to evaluate some limits using L'Hopital's rule. But I would be a terrible teacher if I said that your college professor is going to accept L'Hopital's rule on day one. I mean, the order that Calculus 1 usually goes is limits, derivatives, and then an intro to integrals. But I'm going to let you in on a little secret. Check your work with L'Hopital's rule when appropriate. Okay, so let's take a look at the limit as x approaches 2 for x squared minus 4x plus 4 over x cubed plus 5x squared minus 14x. Well, my first plan of attack is to use direct substitution. So when I use direct substitution for a limit, let me just hide that because I did some work here. I get in my thought bubble because I use cartoons. So I got blank squared minus 4 times blank plus 4 over blank cubed plus 5 times blank squared minus 14 times blank. I'm going to plug in x equals 2 in for the blanks. So I get 4 minus 8 plus 4 over 8 plus 20 minus 28. In other words, 0 over 0. Isaac Newton is not happy. So if Isaac Newton is not happy, that creates a 0 over 0 or an indeterminate form. An indeterminate form in the form of 0 over 0 means that there's a hole in the graph. In pre-calc, we say, that's a hole in the graph, let's give up. In calculus, we say, where is the hole? So let's take a look at the college professor way of doing a limit. So, part one, sorry, I don't want to give away the answer. So what we do is we factor the top. X squared minus 4x plus 4 becomes x minus 2, x minus 2. And the bottom, well, since all three of them have an x in common, I'm going to factor out the greatest common factor of x, leaving me with x times x squared plus 5x minus 14. Anything helpful so far? No? Okay, well, you notice that I can still continue to factor. Let me get my pen. I'm going to factor out this part over here. Come on, green. There we go. So I can still factor out that part. What two numbers multiply to negative 14 and add to 5? Negative 2, positive 7. So I'm going to break this down even more by making this become the limit as x approaches 2 of x minus 2 times x minus 2 over x times x plus 7 times x minus 2. So is there anything that cancels out? Yeah, a pair of x minus 2s. So an x minus 2 on the top over an x minus 2 on the bottom. That's the source of the 0 over 0. But take a look at this problem. Don't be scared of it, because once that cancels out, I'm left with the limit as x approaches 2 of x minus 2 over x times the quantity of x plus 7. Now, is it safe to plug in x equals 2? I know what you're thinking. You guys are looking a little anxious about that top part, because that 2 minus 2 is 0, but is the bottom going to be 0 as well? No. 2 plus 7 is 9. 2 times 9 is 18. If I plug in 0 over 18 into the calculator, that becomes 0. There's nothing wrong with y approaching 0, but we do have a problem with 0 over 0. So even though the limit as x approaches 2 is 0, that just means that there's a hole at 2 comma 0. That doesn't mean that your answer is undefined or that the limit doesn't exist. But we'll get into problems where the limit doesn't exist probably in a couple weeks or so. Okay, let's take a look at problem number 2. Hey, it's the exact same problem. But now that we know that the limit as x approaches 2 for this problem when we plugged in 2 for x in this problem, we knew that we got 0 over 0. Come on. I know you want to. Let's do the cheat code. Let's do L'Hopital's rule. So L'Hopital says that if we get 0 over 0, take the derivative of the top, take the derivative of the bottom. What is the derivative of the top equation going to be? And what's the derivative of the bottom equation going to be? Okay, let's move it to the right. So the derivative of the top equation becomes 2x minus 4. The derivative of the bottom equation becomes 3x squared plus 10x. I'm going to plug in x equals 2. Notice on the top I still get 2 times 2 minus 4, or 4 minus 4. The bottom, I'm going to get 3 times 2 squared would be 3 times 4. Well, 3 times 4, that's a mistake right there. 3 times 4, I don't know how I got 24 there, but the point is, even then, I wanted to plan this out. 3 times 4 would be 12, and 10 times 2 is still 20, but the point is, I still get 22. 0 over anything that isn't 0 is still going to be 0. So even though I messed up on that part right there, whoopsie me. But the point is, if you get 0 on top and a non-zero on the bottom, you still get y equals 0. So as x gets closer and closer and closer to 2, y gets closer and closer and closer to 0. Okay, so let's do some. All right, let's take a look at this. All right, calendar. Oh, I gave away the answer. But the point is there a problem with me plugging in x equals -4? No. So we plug in x equals -4, we get -4 plus 3 over -4 plus 6. You get -1 on top, +2 on the bottom. The limit as x approaches -4 is -1/2. And because direct substitution worked, it's not an indeterminate. It's not an indeterminate form. Therefore, as x gets closer and closer to -4, y gets closer and closer to -1/2, and that point, -4, -1/2, actually exists. See if you can do problem number 4 in both ways. So there'll be a problem number 4 and problem number 5 that's the exact same problem. See if you can do this problem independently. Okay, so my first move is to apply direct substitution. Do you think direct substitution is going to work here? So I get my brain. Here's my brain. Yes, it's squiggly. Looks like a cloud. Looks like a comic book. 5 minus 5 over 5 squared minus 25. Isaac Newton is not happy. There's a hole in the graph because it creates the indeterminate form 0 over 0. I'm not happy with that. But can I factor out the hole in this graph? So x minus 5, I can't really do anything about it. But I can factor the bottom into x plus 5, x minus 5. Can anything cancel out? Yeah. X minus 5 on top and x minus 5 on the bottom cancel out. Therefore, what's left on the top? So I can interpret this as the limit as x approaches 5 for 1 over x plus 5. Is direct substitution going to be a problem? Nope. So now I'm going to apply 1 over 5 plus 5, or 1/10, which means as x gets closer and closer and closer to 5, y gets closer and closer and closer to 1/10, but that point is a hole. Do you understand? Okay, but I know you like to use L'Hopital rule. Me too, I love L'Hopital. So let's take a look at this problem yet again. Spoiler alert, we learned that before, it was a hole in the graph. So let's take the derivative of the top and the derivative of the bottom and hope that that problem goes away. What is the derivative of the top? What is the derivative of the bottom? So it becomes the limit as x approaches 5 by L'Hopital's rule is 1 over 2x, because the derivative of -5 is, the derivative of x is 1, the derivative of -5 is 0, the derivative of x squared is 2x, and the derivative of -25 is also 0. So now, is it legal for me to plug in x equals 5? Yeah. 1 over 2 times 5 is still 1/10. Do you overstand? Okay. Let's take a look at the next problem. The limit as x approaches -4 for x plus 3 quantity to the 1984th power. I see what the book was trying to do here. Is it legal to plug in x equals -4? I don't see any harm in it. I don't get 0 over 0 or anything. So let's plug it in, and we get negative 4 plus 3 quantity to the 1984 power. I wasn't born in that year, but I assume it was a good year. So we get negative 1 quantity to the 1984 power. Well, let's use common sense. So if I have negative 1 quantity to the first power, that's just negative 1. If I have negative 1 quantity squared, that's negative 1 times negative 1, that's going to be positive 1. And yet if I have negative 1 quantity to the third power, it's going to be negative 1. And if I apply negative 1 times negative 1 times negative 1 times negative 1, there's an even number of negatives. So if there's an even number of negatives, it's going to be a positive, and you know that a bunch of 1's being multiplied makes 1. So as x gets closer and closer and closer to negative 4, y gets closer and closer and closer to positive 1. And does that point actually exist, negative 4 comma 1? Oh yeah, that exists. All right, let's take a look at problem number 7 now. I don't want to spoil. So let's say I have this problem. So I used V just to get a little bit of variety. V for variety. So let's say I use my thoughts. I go V cubed minus 8 over V to the 4th minus 16, and I want to figure out where does the function want to go as V gets closer and closer and closer to 2. So if I plug in 2, I get 8 minus 8 over 16 minus 16. You know the drill. It's a hole in the graph. And even though in algebra there is a formula for the difference of cubes, you know that V cubed minus 2 cubed, there's a formula for that. And you could break down V to the 4th minus 16 into V squared plus 4V squared minus... You know what? I'm tired. I want the one size fits all. If it's 0 over 0, I'm using L'Hopital. L'Hopital is my best friend. So I'm going to do the limit as V approaches 2, but I'm going to differentiate the top, and I'm going to differentiate the bottom, and you're not going to stop me. So I'm going to do the derivative of V cubed minus 8, and that's going to get me 3V squared. And the bottom is going to get me 4V to the 3rd power. Now, is it legal to plug in V equals 2? Yeah. So that gets me 3 times 2 squared over 4 times 2 cubed, which is going to get me, well, 3 times 4 over 4 times 8. I suppose you could have made this 12 over 32, but your professor is going to want a simplified fraction. And I just figured I'd just do you guys a favor. Cancel out any common factors on the top and bottom, and you'll get 3/8. So even though 2 comma 3/8 is a hole in the graph, that's the limit. Now, I'm going to have a little fun. This kind of problem. This used to drive me insane. And if you guys want to know the secret to this one, yeah, it's L'Hopital. But the point is, in college, they're going to teach you a method called multiplying by the conjugate. Whenever there's a square root and you have 0 over 0, chances are you want to multiply by the conjugate with the radical. Let me get my pen. So in this case, let's say you're in college and you have a problem like this. What you would do is multiply the top and bottom by the square root of x squared plus 8 plus 3. So you would multiply that on top and bottom. But I don't want to confuse you guys. I want to give you guys the cheat code. If I plug in x equals negative 1, you'll notice I get 0 over 0. You know what that means. It's a hole in the graph. I'm not happy. I'm going to use L'Hopital. Say it with me now. L'Hopital. I heard you. I did. We're on a computer. So I'm going to cover up this because I don't want to show off my spoiler answer. Can I convert the square root into something a little bit more manageable? Yeah, I can make x squared plus 8, all that to the 1/2 power minus 3. And I'm going to prime it. I'm just going to get a little bit ahead of myself. The derivative of x plus 1 is just 1 because the derivative of x is just 1. So now let's take a look at x squared plus 8 to the 1/2 power. Go back. Dust off those cobwebs. How do I differentiate x squared plus 8 to the 1/2 power? The chain rule. So I've got x squared plus 8 as my blah. So if I have blah to the 1/2 power, how do I take the derivative of blah to the 1/2 power? That'd be 1/2 blah to the negative 1/2 power times blah prime. So let's do that. So that would be 1/2 x squared plus 8. Oh, I think I messed up on this problem. But just to make it up to you, yeah, I messed up on this problem. I just looked at it right now. I didn't do any editing. I apologize. I'll come back to this and I'll make it up to you. I promise. I promise I'll make it up to you. I made a mistake. So I'm going to come back to it. All right. Number 9. The limit as x approaches 0 for 5x plus 4 minus 2 over x. I get the direct substitution is going to get me 0 over 0. I'm not happy. I'm not happy. There's a hole in my graph. So what that means is I take the derivative of the top and the derivative of the bottom. So I get the limit as x approaches 0 for 5x plus 4 to the 1/2 power minus 2 over x. And I'm going to differentiate the top and differentiate the bottom. Oh, come on. There we go. So I'm going to prime the top, prime the bottom, d dx the top, d dx the bottom. So that gets me 1/2 5x plus 4 to the negative 1/2 power, and I'm going to differentiate the inner function 5x plus 4, and that's just going to be 5. That minus 2 goes away, and that x becomes 1. Okay? Well, at this point, is the denominator even important if all that's over 1? Well, no. So now I've got, well, I'm going to make this 5 times 1/2. I'm going to make that 5 halves. And remember that a negative exponent becomes a positive exponent on the bottom, and the 1/2 power is the square root. So I'm going to make that 5 halves times 1 over the square root of 5x plus 4. So that leaves me with 5 over 2 square root of 5x plus 4. And I'm going to apply direct substitution. Hopefully it does not mess up. 5 times 0 is 0 plus 4. We got the square root of 4. So 5 over 2 times the square root of 4, or 5 over 2 times 2. The limit as x approaches 0 is 5/4. But that point does not actually exist because it's a hole at 0, 1.25. Do you understand? Let's take a look at number 10. This was a relatively easy one. I really want to get back to number 8. That's why it hurts me. It hurts my feelings. So I've got the limit as x approaches 0, and I apply direct substitution. I know that that 5 on the top is not going to hurt me and make a hole in the graph. So therefore, I get the same thing. It's a different problem, but I got the same result. Okay? It really does hurt me. What's that? What was that problem again? Okay. Limit as x approaches -1 for x squared plus 8. Okay. X squared plus 8. I'm going to write that on the side really quick. Over minus 3. All that over x plus 1. Okay, I promise. I'm going to do this right because I don't want to mess up. Okay, so let's say I do this problem on the side. So, you guys know that there's a blah on the inside. It's an indeterminate form, but I'm going to do this whole thing as 1/2 blah to the negative 1/2 power blah prime. I'm going to do this right. Okay. I have a bachelor's degree, and it's way too late in the video for me to try it again. No, I'm just kidding. I really care. I want to make this right. So I differentiate the top by L'Hopital rule. So I'm going to differentiate that, make that L'Hopital. And I differentiated this part. The rest is going to be easy. The derivative of -3 is gone. The derivative of x plus 1 is 1. And now it just becomes the limit as x approaches -1. So I'm going to get 1/2 of x squared plus 8 to the -1/2 power. And the derivative of x squared plus 8 is 2x. So, and all this is over 1. You know what? I don't even need that denominator. But I do know that I can cancel out half of 2x by just making that x. So now, this is literally going to be the limit as x approaches -1. Notice that this x stays on top. This becomes the square root in the bottom. So that becomes x squared plus 8. Now, is there a problem with me plugging in x equals -1? No, because that's going to be -1 on top. And that one, I can see where this is going. So let's plug in -1. And let's plug in -1 on the bottom as well. So that's going to get me -1 on top over -1 quantity squared plus 8 inside the square root. So that's going to be -1 over 1 plus 8, which is 9. So that's -1 over the square root of 9, or -1/3. But that point does not actually exist because of that indeterminate form. Sorry, I know it was a bit rushed at the end. I just don't like to make mistakes when it could prove costly. Hope you guys had a great Monday. Laugh at yourselves. We all make mistakes. Have a good day.